Welcome back, Generals, to another Let's Fix It. Generals 0 hour to make the best game ever. And we are still developing unassemblize tool. And I got word from Baptista that I should now be able to push to this branch. Let's see. Push. Why does it? Hold on. I'm a bit confused. Why does it say 10 changes? There should be only 2, right? Huh? I don't understand why it says 10 here. I only added 2 commits here. They're just 2 commits. Nothing else. Oh, let's see what happens. I mean, in the worst case, everything breaks, right? Okay, so basically, we should now have 2 commits here at the end. Yeah, we do. Okay, I don't know what was up there. Good. So from my side, this can be merged. Yeah. Implement. How do we call this? Maybe this here. Implement. Yeah. Okay. Good. Then we can go back to here. And then we can delete this branch. Delete, false. Yes. Okay, and then we pull this. And hopefully it compiles. Okay. Yeah. Good. Then that's done. I forgot to approve this review, but well, who cares? Okay. Then let's close this. Okay, so we want to add thread safety here. So let me see what C++ threads. I know there's a lock guard. What about Oops. Mutex. Mutex, recursive mutex. No, I think it's just mutex. Yeah, just mutex. What is a shared mutex? Shared data. Share ownership. Ah, right. I think we need a we need a lock that has a read and write lock. Read and write lock. Protect shared data from being simultaneously accessed. Exclusive access. Shared. Several threads can share ownership of the same mutex. Exclusive. If one thread has acquired the shared lock, exclusive, but can acquire the shared lock. Yeah, okay, so the shared lock, it allows us to have like multiple reads. Yeah. Okay. I think this is the guy we want to use. So so we will include shared mutex and mutable. Find content. Yeah, we need a mutable shared mutex std shared mutex. Okay, so let's see. Well, here we do have a write. Okay, so I think we have std lock guards, lock shared mutex, size. This is just a read, so here we can do. Is there shared lock guards? Std shared lock guards. Shared lock. Read lock, write lock. I don't understand what's going on here. What is this thing? Ah. Shared lock. I see. Then what's the difference between a unique lock and a lock guard? Lock guard versus unique lock. Unique lock. Differences. So why is there no shared lock guard then? If these things are different. Shared lock guards. It's not part. It's kind of weird that there's no shared lock guard in C++. Okay, well, we can add it to our util. How about that? Shared lock guards. Shared mutex. Mutex type. Using mutex type equals that. Lock shared. Adopt lock T. What is that? If we don't know it, delete it. Okay. Okay. Okay, so util shared lock guards, and that doesn't work. Includes util .h. There we go. Okay, so shared lock guards. Okay. So insert certainly needs the right lock. Right lock. Maybe we take another note here. AKA reads lock guards. Okay, so here's a lock. Yeah. Std move. Content. Make pair name. There. This one is single threaded. Here we have another access IT. So this is bool bool found if found found equal it is not end. And here we need a lock for, so this is a read lock as well. So we take the shared lock, put that here. File read, yeah. Content, boof. Yeah. Okay, this to me. Oh, here we have some problem. IT. Oh, insert IT. Insert. Iterator where? Oh. Oof. Well, we can't use this here anymore. Load content, find content. Find content. Why don't we simply call find content here to begin with? Maybe. Okay, so this insert down here, essentially we need to emplace, I think. Emplace without the iterator. Oh, that doesn't work. Std map. Merge. Insert elements, insert range, insert. Okay, so if you give a pause, then you just get an iterator. Otherwise, you get a pair. If we have a separate lookup here, let's say there are two callers are racing for this load content on the same file, then they could both pass past here and then they could both load the file and then both try to emplace it here, and then only one of them will succeed and the other one was for nothing, was a useless file read. So maybe we also need to save like well, maybe shit. I think taking a log for the whole duration of this load content is quite a bit extreme, right? Because if this file read takes a long time, then the UI thread won't be able to load, to access this content storage. So that's not good. So the log needs to be short. Yeah. We could have like we could have another container that stores like things that we now request to load, and also if there's a second load request, then it can also check that pending loads list and then say, okay, someone else already is about to load this thing. But hold on, how about we could already emplace it here. We could emplace it already on the search, but then the problem is if it fails to load, then it needs to remove it again. I would prefer to not push something into the files map when it's not yet ready. Like placing an empty content in there, it's pretty dirty. Let's not do that. So I'm inclined to have like a separate vector. And that vector, we just push back the name. Here, this name that we are about to load. But then the question is, what does the other guy then return here? He cannot return already loaded because we don't know if the load will actually succeed. He cannot return loaded as well. Yeah. Do we do anything with the return results? Well. We use the result, yeah. Oof. That's a problem. Oh, this is a problem. Yeah. It is a problem. If we have a fast exit on load content because some other thread is already loading that particular file, then we don't have a result at this place here. Right. We don't know if it's failed or succeeded or already loaded, or we only know that it is pending, but we don't know. So there's a chance that it could fail here, and then has loaded source file would have the wrong results. Yeah. Oh, yeah, this is not good. Oh, there must be some solution. There probably is some solution. I'm not seeing it right now, though. Okay, let's see. It has failed. It has not failed. Oh boy. Well, the find storage still has a reader lock. So if we put a write lock into load storage, then it's probably fine. Because it will be just two threads will wait on each other. Or more. But yeah, I guess it's fine. Yeah. Yeah. It's probably fine. As long as the UI thread is not negatively affected by the lock. Ah, no, hold on. If there's a writer lock, then the shared lock cannot, the reader lock cannot be taken. No, it is a problem. Okay, it still is a problem. Shit. So, whoa, I don't know. Oh. Oh. Oh my. I don't know. I don't know. It's a complicated problem. Well, maybe we shouldn't use a lock then. Maybe we should use... Man. Lock. Maybe we can work with two locks. Yeah. So how about we create a files map mutex, and then we also create a regular mutex files load mutex. Mutex taken before loading file from disk. Mutex taken when accessing, when reading or writing files map. Why is mutex not noun words? Okay. This could work, yeah. So we can here do if find content name equals not a pointer, then we know it's already loaded, right? Yeah, so we can do this. Then we can delete all this stuff here. Good. And so the shared log, fast lookup. Ooh, fast lookup, search map. We need to take a log here, shared log, right? Because this one needs logging, because it can be changed here and here. Yeah. And here, this one also needs, yeah, okay. I think this log is perfectly fine. Yeah. And then here, so how about here we take this log, the log guards here, log guards. How about we call this read log? Read log. Read log. Write log. And so this is write log 1. And then here we have another write log 2. And then we have files load mutex. How about we call it just load file mutex, or yeah, load file mutex. Okay, and so essentially we take it here, the whole duration. Then we take this one here, and then we have here auto IT edit Here we put IT, and we put assert edit. Somehow it doesn't like it. And oh, assert is not known. Oh. Include assert. Okay. Okay, so essentially here, after this lock is taken, we hold on. After the lock is taken, we need to search again. We again need to search here this, and that. Second search. Well, fast pass, look up search map. Okay, so the question is, should we use this or should we use this? So should we again search this way or this way? I'm not sure. Here we get the benefit of okay, let's document this one here. Take exclusive mutex to prevent multiple threads potentially loading the same file. Okay. Yeah, so the question is, do we want to find or call this again? Here it has a benefit of this one. It's already loaded. Yeah. Take exclusive mutex. I mean, it needs to do it anyway, so I think this is fine. I think this is fine, yeah. And then we pass the iterator here, do an insert, and do it here. I like the way it was. This way. Yeah. And then we need to take out the iterator here and create a new scope. And assign this here. And then create another shared lock here. Then we call it now the question is, do we really need this then here? I don't think we need this up here then. Just do it like this. Yeah. Okay, so we have a load file mutex here, so there can only be ever one load at a time, which prevents a whole lot of problems. Okay, and then here it checks if it already exists. If it does, then early exit, done. If it does not exist and needs to load it, it tries to load it, eventually loads it here, and it sets it, and then the job is done. Otherwise it fails, and every caller gets a correct result. Yeah. Yeah. I think this makes the most sense. Yeah. Okay, is everything got it then? Shared, lock guards, write lock, read lock, write lock. Is there any chance of deadlock here? I don't think so. No, I don't think so. No, I think that is fine. Yeah. It probably is fine. Since we don't have multiple threads running right now, we can't really test it. So yeah, as long as it compiles, I guess it's fine, and that's about it. Yeah. Following file, reading or writing files. Well, we should also delete the copy constructor. Let's copy this guy here. Yeah, I think that should be it. Yeah. Yeah. Music is taken before loading a file from disk. Music is taken when reading or writing the map. I think this one doesn't need to be mutable. Does this one need to be mutable? Yeah. Mutable. Okay, good. Okay, good. I think that would be it. Let's see if things still run. Yeah. Good. I think that works. Then we should be able to commit this. All right, so we added a lock, read lock guard, shared lock guard, mutex. Well, let's call this mutex. Oops. Mutex. And then we call this mutex. All right. Maybe we could put here alias read lock guards. Yeah, looks good. Okay, so shared mutex. On that note, we also use the regular mutex. Maybe we should also include the regular mutex in. Where's it? Here. Mutex. Good. We deleted all these guys. Mutex taken when reading or writing the map. Mutex taken before loading a file from disk. Yeah. Util is set. Okay. And read log. Files map mutex. Yeah. Take exclusive mutex spread multiple threads potentially loading the same file. Load file mutex. Yeah. Then we have an iterator here. We take a shared log. We assign this find if it is not end is already loaded. Yeah, this looks good. And here another log, write log, files map mutext, and yeah, this is the same. Then we have a read log here, shared log mutex, and here we have a write log on clear. Yeah. Yeah. That that looks good to me. Make file content storage thread safe. File content storage thread safe. Make file content storage thread safe. Yeah, well, it's. I hope I made no mistake. Maybe something is not quite right, but I think it's okay. Good. We can also stash pop, by the way, and we have conflicts. Because of the to do. Yeah. Good. Yeah. Then let's we could also have an unordered map here with unique pointers to file content theory. Yeah. All right. Good. What's next then? We can probably start thinking about generating the UI elements for the disassembled functions and comparison, right? Yeah. Or is there any other to do that we should do? Let's see, to do. There are a bunch of to-dos for our UI here. split into smaller functions. Yeah, we can do this later. Clippers you can also add later. Yeah, here we can probably also remove all this stuff here, and PDB address can also be made smaller. Like we don't use this address. We do use this though. How big is this thing? Yeah, by removing this one, we would save 8 bytes here. Maybe we should remove this here. Alternatively, this could maybe be just 2 bytes, because section, like we won't have many sections, and offset is probably also not large. I don't know. It's nothing to worry about now, I think. Good. Yeah, then I think the next in line would be to draw some table. Yeah. So yeah. So now the question is, how do we want to do this then? Let's start. So when we load files here, I suspect we do it similar to the stuff here. Draw the table and well, the question is, should it be like should it be 2 tables next to each other, or should it be 1 table? There, yeah. So it could either be like one table like this, and then you have a scroll bar here at the bottom, but that's kind of weird. It's not like maybe it would be good if so there was one side here, and then in the center there is like a small column with the comparison here, like matches, mismatch, and so on, right? And then on the other side we also have then for the other file the disassembly and so on. And then you can scroll both individually, left and right, but the scrolling up and down, that would have to be uniform. So so it's a question like, is there maybe a way to tables horizontal scrolling? Mm-hmm. It would be good to know if there's a way to like scroll two sides at once. Maybe there's. I don't know. Maybe it can be embedded into a child window. Which gives then this scroll wheel. Maybe. I do wonder how this is implemented for the ones we already have. Scroll Y, file manager, info table, begin table, resize Y. Oh, okay. It's not entirely clear to me how it should look. I suspect the simplest way would be have it in one table, right? That spans here over the whole width of this window, right? But then I don't know, it's maybe weird because I don't know. Maybe it's fine. Maybe it's fine. I think it would be fairly complicated to make like one window here, then have another here, a column for the comparison, and then a separate window here for the other side. And all these things in sync when you scroll, and yeah, this could be really a problem. So I think this here, the way it's here in one table, is probably the easiest implementation wise. The only problem is then that the comparison indicator is not necessarily always in view, where we would have it in the center of the columns. Yeah, we would highlight we can highlight the colors of these rows. Yeah. Maybe it would be fine. Maybe not. We probably need to see it, yeah, and then experiment a bit with the flags, yeah. It would be great if it was somehow split. But yeah, it's... this scroll Y thingy. So it's a table flag. It's just table. Maybe we first implement it with one table and see how it looks. And if we think that it doesn't look all that great, then we experiment with some other ways and see if we can make it other way. Otherwise, we fall back to the simple way. Well, I'm pretty sure we get it correctly to work if we do it in the same style as this table, right? You can scroll here, you can scroll here, and you can resize it. So this is all we need essentially, but it would be nice if we had like a fixed column in the center and then a table on the left, a table on the right with each their own X scroller, but the same Y scroller. And then so that if you scroll one side, the center column with a comparison node doesn't change. You can see this side and you can see this side, and you can look at them at different positions. Yeah, I think this would be optimal. This would be, yeah, like from a user experience, it would be better than having it all in one table, because here, like, you need to look at one side and then you need to look at the other, and maybe you need to go back and forth. I don't know. Could be awkward to use. Maybe we can ask Chat GPT for some impressions. Imgui. can we embed a imgui table into a child window? Or can we embed a imgui table into a child window where the child window owns the Y scroll instead of the table? Yes. Vertical scrolling to the child window. Okay. Man, this thing renders slow here. Jesus Christ. Okay, so there's a begin child. Always vertical scroll bar. Oh, so... Huh? Wait, so a child window can take this? Hold on. Begin child. Oh, it takes... no, hold on. Begin child frame... What? Huh? Here. Aha. So it takes child flags and window flags. Aha. I see. So window flags has vertical scroll bar. Okay. So maybe we do that then, yeah. Yeah. Let's see. Table column, which stretch? Here. Yeah, I think we can try this. Yeah. So basically we create a child with this always vertical scroll bar. And in this child we create a table with 3 columns. And then in all 3 columns there will be another table. For the left function on the left column, right function on the right column, and in the center column the comparison indicator. Yeah. 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 I think we can try this. Should we already draft it? What's the time? 1 hour 30. Yeah, we can do a couple more minutes, I guess. But I kind of would like to take a break this evening. I've been like very busy the last evenings, always working. Maybe a little free evening would be good. Yeah. Okay, so let's see. So Draw functions, multi-select box. Okay. Yeah, for now we just all dump it here into this one function. It's fine. We split it later. So we are looking at essentially we create a new scope here. Let's call this draw functions. So we probably want to draw it in, let's see, file manager info, file manager info. Jesus. We probably want to draw it in a tree node, right? Tree nodes. So down here. So we will have. Well, let's see. Okay, the question also is, how do we want to draw, like, I mean, in what order should the functions be drawn? First matched functions, then unmatched functions, maybe? Yeah. I'm not sure. Well, ideally, the selection shows in the same order as it does in our selection. Functions the same order as in our selection, respective to the site. Yeah. But then we would need to iterate over all selected functions, check if there's a matched function in there. Matched. Okay, but we get a matched index and then you can look straight in there. Okay, but this works. This works. Yeah. We can do this. Luckily. Okay, so we do. Good question. Well, makes it more complicated. Matched functions. Ugh. Okay, so one way to do it is we in our comparison descriptor, we go through all selected named function indices. So you have oh my gosh. Here, descriptor. Descriptor dot this indices and wait, hold on. That is not the selected matched function indices, right? So it's index t index goods. And then that would be 1, and then we could do for it. Let's call this matched. Yeah, matched function index. Let's be specific. Then we have index t. Let's do I0, I smaller 2, plus I. And then actually, yeah, we probably need an index here. Then we have for files, descriptor I dot selected named function indices, and we call that selected named function index, right? So this is how we could go through, but then it would mean that it would first show a list of the matched functions and then of left named functions, unmatched ones, and then right side unmatched named functions, right? The question is that okay, or do we want these things to be intertwined? So you have like an unmatched function, and then if the next one is a matched function, then you show the matched function. But then the problem is, yeah, it's a problem because you can have selections on both sides, right? And then what? Then you would potentially show the same matched function twice, right? That doesn't make much sense. Well, you could remember which matched functions you have already you have shown. No, you haven't shown all. Yeah. So yeah. Yeah. So here we would say say comparison file program comparison descriptor file equals this thing const file. Then we also have program revision descriptor revision descriptor file dot revision descriptor dot get, and then we would say if file dot how about we add another function here. Bool is matched function to index t named function index const. Assert name function index smaller than match infos dot size, return that name function index dot is matched function, and we can also have a get matched function index index t. Let's do the same, assert return get matched index. Oh, it's not a function. There we go. Now, I think we call this function a couple times as match info. can simplify this here. Is matched function index and so we say if file is matched function, then we continue, skip this guy. Yeah, okay, so what we can do is we can show all the matched functions, then the unmatched ones. Yeah, I guess, but it's not ideal because then things are out of order. Yeah, but no one is looking at a huge list anyway, right? Yeah. Okay. Okay, so selected matched function indices, the selected named function. Yeah. Okay, so for starters, let's just put in here the tree nodes. So well, okay, file dot no revision descriptor. Can probably make it like so. So revision descriptor dot Revision descriptor. Named functions. Named function index. Don't we have a helper function for this as well? Let's see. Get filtered named function. Okay, let's do here named function const get named function index t const assert well, I mean the amount of asserts gets absurd here. Maybe we shouldn't do that. Let's comment this out again. Okay, back to our MGUI app. Scroll down. Name function index const named function and then we can say here, I don't know if that makes a lot of sense. Tree name CSTR. I'm a bit afraid of duplicates here. Maybe. Yeah, that could be duplicates now. Maybe. Okay, and here we would say const matched function equals descriptor matched functions, matched function index, matched function dot name dot cstr. Okay. No. Oh, links to named functions. Okay. Then we do const named function named function 0 equals named function we probably need file. Probably std array const that to equals no revision descriptor array equals descriptor and files 0 dot m file revision descriptor dot get and another one. Okay, and then we need a name function const named functions array, and we do m named functions. Like this. Right, 1. Okay, and then that will be used here. Oh, do we really need, hold on. I think we just need name function. Const named function, named functions, and then we index to, oh boy, matched function index, matched function. Let's put this up here. So it will be matched function dot name index pair 0. There we go. Oh boy. And 1. Okay. Okay. And then essentially we now have named function array. So the tree should be here, named function array 0. We can take any of these. Dot, no, name CSTR. There we go. Okay, so this should now at least show us the matched functions and then the unmatched functions of the selections we make without anything inside. Yeah. Let's see. Compare. Yeah, there we go. Yeah, I think this makes sense. It probably shouldn't be collapsed by default. Tree nodes. How can we... Let's see. tree node. I think that's a question for ChatGPT. Can we create a tree? Can we create a imgui tree node that is not collapsed by default? Yes, default open. Oh, tree node X. I see. Okay. I missed that. Yeah, okay. Yeah. What else do we have? Oh. Framed. Default open. Leave bullets. Span available with draw frame with background. Draw frame with background. I wonder if that makes sense. Let's experiment a little bit with it. Let's create a copy of all these flags here. And let's make a const expr tree node flags int. So we want to have default open, yeah. And maybe framed, I don't know. Span available with, maybe that makes sense. Let's see how it looks. Okay, so we do tree node X. And we pass the flags. Imgui tree node flags. Imgui tree node flags. Yeah. BX. There we go. Okay. Okay, let's rebuild and recheck. Compare. Good. So then we can select this stuff, and yeah, so now it puts these huge thingies here. It kind of makes sense, gives you a lot of clicking space. Well, like here, this one gives you very little clicking space. This info thingy. I do wonder though if it really makes sense to have this framed style. Maybe we shouldn't do frames. Let's search for this info thingy. Info. Let's also give it the span available with 3 nodes. Put it in place. Okay, let's see how that looks and feels. So now we can select these guys here on the whole row, which I guess makes sense. Yeah, I think that's not bad. Yeah, gives a bit more clicking space. Yeah. Okay, so. Yeah, I think this is better. Like, then you don't have to aim really hard to select it, but you can just hover over here. Okay, so if we go to compile and bundle, single bundle, and we select all, now I'm curious if we have any conflicts here, which is possible down here, right? Here, see? Yes. Oof, that's a problem. Okay, but other than this, we should have unique names here. And now if we also select these guys here, then I think we will have serious trouble. Actually, it's still very fast. But we will probably have big troubles if we try to allocate here new string IDs for this stuff. Then this will become super slow. Yeah. Okay, but I guess someone shouldn't select so many things, right? Yeah. Yeah. Okay, let's worry about this in the next session. I think for now we take a break here. Has been 2 hours 10. Yeah. Okay. Yeah, so we will have like these functions here. Yeah. Yeah. Good. Then I will take a break here. Then, yeah, I wish you a great day or night until next time. Goodbye.